scientists just figured out how to use quantum computers to predict the exact forces between atoms in a chemical reaction. And if you're wondering why this matters, this breakthrough could literally help us pull carbon dioxide out of the atmosphere more efficiently. IonQ just published research showing they can calculate these molecular forces with better accuracy than traditional supercomputers. But there's a catch that nobody's talking about. Let me explain. So first, what are we even talking about here? When molecules interact, like when a carbon capture material grabs CO2 from the air, atoms push and pull on each other with specific forces. If you can accurately predict those forces, you can design better materials, optimize drug molecules, or figure out exactly how a chemical reaction happens. The problem? Calculating these forces is brutally difficult. Classical computers can handle simple molecules, but when you get into complex systems where electrons are strongly interacting, what scientists call strongly correlated systems, traditional methods start falling apart, literally giving you the wrong answer. That's where quantum computing comes in. IonQ partnered with Hyundai Motor Company to tackle this using something called quantum classical AFQMC. I know, alphabetical soup, but here's what makes it clever. They're using quantum circuits to handle the gnarly quantum mechanics part, while classical computers do the heavy statistical lifting. The breakthrough here is they figured out how to reduce the statistical noise that normally makes these calculations useless. Think of it like this. Imagine trying to measure the weight difference between two nearly identical objects on a scale that's constantly vibrating. You'd get wildly different readings each time. They essentially found a way to sync up those vibrations so the differences become clear. They tested this on real systems, nitrogen molecules being pulled apart, hydrogen chains, stretched carbon dioxide, and crucially, the actual chemical reaction that happens in industrial carbon capture systems. For that MEA CO2 reaction Hyundai cares about, their method matched the best classical approaches, but worked even in regimes where traditional methods completely break down. Here's the part that's important though. This research was done entirely on classical simulators, pretending to be quantum computers. They haven't actually run this on real quantum hardware yet. So when IonQ's CEO says this demonstrates a clear path for quantum computing to enhance chemical simulations, he's right, but we're talking about a roadmap, not a product you can use today. What makes this genuinely exciting though is that the methodology is ready to go. When quantum computers get powerful enough, and companies like IonQ are building them as we speak, this exact approach can be deployed for real-world problems. We're talking about designing better batteries, more efficient solar cells, new pharmaceuticals, and yeah, materials that can actually make a dent in climate change by capturing carbon at scale. The algorithm works. Now we're just waiting for the hardware to catch up. And based on the progress we're seeing, that might happen sooner than you think.